Hi, everyone. We're going to talk today about springs and spring forces. So, we did a lab in class where you each had a spring and you added different amounts of weight to that spring. And what we saw is if we added a little weight to the spring, it extended a little. And if we added a lot of weight to the spring, it extended a lot. And so we graphed that and we looked at for the amount of extension, which we'll call X, and we measured that eventually in meters is what we got it to. And the amount of force we applied in newtons, and we measured that through the force of gravity on the mass. We saw a pattern that looked essentially like this, and we decided overall that this was a proportional relationship between the force and the extension. And one of the really important things that we learned here was that the slope of this line, so our slope here, has a unit of newtons per meter. And we call that slope K, or the spring constant. And again, it's measured in newtons per meter. So what that ends up meaning is that it's essentially how many newtons of force would I need to apply to make this string stretch 1 whole meter. What's really cool about this is that it also suggests that the relationship between the extension of a spring and the force applied to that spring is pretty straightforward. Because just as we know that a proportional force is y equals mx, or a proportional pattern is y equals mx, we know that this force, what we have on the y-axis, is equal to that spring constant times x, the extension. And I am, for this one, going to add a little absolute value here, because at this level of physics, I don't want us to worry too hard about the positive and negative of this spring force. For the record, let's think about this a little bit. If we stretch the spring out, what does it want to do? So if we pull it this way, what does it want to do? It wants to pull back. And similarly, if we scrunch that spring up, so we push it in, what does it want to do? It wants to pop out. So this is something where when you get to AP Physics, if that's a choice that you end up making, we will learn that there's a negative sign here, and that essentially the force of the spring is always opposite the extension of the spring. If you extend it, then it's going to try to get smaller. If you push it, it's going to try to get bigger. We also discussed in class that there are two big uses for springs outside of just the little metal coils that we used in class. And it's one of the reasons that knowing about springs and knowing about the forces is pretty important. And we're going to come back to springs again when we talk about energy, because springs are a really good way of thinking about potential energy in particular. But the two reasons that we really use springs a lot in science, first, they're a really good simulation of a chemical bond, in that bonds are not just a stick between two atoms, right? There is some of this flexibility, but it doesn't want to be too flexible, right? So if you try to go too far, you're going to have a lot of force trying to pull that chemical bond back. And the second one is more of a material science point of view, but in particular, the Young's modulus is this idea that all of our materials that we work with most commonly, concrete, metal, literally everything I can think of off the top of my head, for some amount of time acts like a spring when we start to put force on it. So if we put a piece of metal in between two bars and we stretch it, what we see is it acts like a spring. It wants to restore itself. And eventually that stops and it stretches permanently. Um, but for that portion of time where it acts like a spring, it has what's called a Young's modulus, which is essentially just a spring constant for that material. And we, if we are civil engineers or architects, take that into account when we think about the strength of the material and how it can move or deflect or deform when we kind of put people in a building or put other forces on the building. All right, that's our talk about springs. Thank you so much. Have a great day.